Hello, everyone. Welcome to today's presentation. When you start a data engineering project, you may have questions of, what we need to build, how do we do it, what does the data looks like, um, and natural questions about the process to building out your solution. One of the things that we often talk about or do not think as much is where's this solution, where's this data engineering solution is going to be running from, what, what is going to be hosting your data pipelines, how do we monitor the health of your processes, is there, what are all these different tools and infrastructure requirements that we need to create in order to have a process that can be repeated, that can be tested and deployed properly. So if you ever had those questions with today's presentation, we'll be able to provide answers about how to start a data engineering project from the concepts of the blueprint, the requirements, and how to build the design and the planning phase in a data engineering project. Welcome, everyone. My name is Oscar Garcia. Um, I'm a data engineer and system engineers, and I also work on AI solutions. So with today's presentation, we are addressing the concept of the importance of design and planning. But before we do that, let's talk about data engineering overview first. So data engineering is a process that involves executing several steps, right? We need to understand the problem, what are we solving, the scope of work, the design and architecture for creating our solution. This enables the ongoing big data analysis using analytical and visualization tools. So the end goal of a data engineering process is to be able to process some data and be able to create the solution for this data to be available for analytical and visualization purposes. So in today's presentation, we are addressing things about design and planning, system design and architecture, data pipeline, in orchestration. They mean what are those things, right? What are those areas of our data engineering solution? And we address things like source control and continuous integration, continuous delivery. We talk about Docker containers and how they are relevant for a data engineering solution. And we talk about cloud infrastructure, uh, how to, and what does that mean, right? What is the importance? To follow this process, we have a GitHub repo that has all this information and has the code available to you. You can visit that site right there, that link that gives you the information, the source code, and some of the materials. We'll be emailing the materials after this, the recording, the presentation material at the conclusion of this presentation. But let's move on. All right, let's talk about the importance of design and plan. Design and plan is really it's a crucial phase of data engineering because it helps us lay out the foundation for our solution, right? Our goals here is to create a successful and scalable solution and repeatable solution. And by that, what we mean is to be able to not only build it one time, but be able to continuously improve it, upgrade it, and manage it, right? Support it. So this phase ensures that the architecture and strategy align with the business goals, right? We optimize resource utilization and we mitigate potential risk. So the whole planning here is to be able to understand that there is a business need to deliver something, and how we're going to go about to build the solution, how we're going to host it, and what are the things that we're going to be able to do to optimize the resources that we're using in a technical and a financial sense, and also mitigate for any risk like outages or errors on the system. Some of the foundational areas that we need to talk about are things like designing the data pipeline and technologies, specifications like data flows, what coding language we're going to use, data governance, and tools. So basically here, data pipeline is that is the area of the code that we're going to build. Whether we're going to use Python or we're going to use some tools out there to enable to move data from point A to point B, and what kind of what tools are we going to use, right? Especially, are we using, is it a code solution, code centric solution, or is it a no code solution, right? And what are the data governance and tools that we can use, which is very important for a data engineering project. Data governance is how we manage the process around this solution, the security, the visibility, monitor services, and so on. It's very, very important. We also need to define the system architecture, whether it's cloud services or on-prem. These days, most of it is cloud services, and our focus is cloud services to build a scalable data platform. We also talk about source control and deployment automation with continuous integrations and continuous delivery pipelines. And that basically what it means is, okay, so we are coding something. We are orchestrating the deployment of something. And also we are provisioning resources. How do we manage this? How do we deploy this? Do we keep this in source control? And I'm not just focusing on the actual data pipeline code, but we're talking about infrastructure. How do we manage the resources and the code for the infrastructure that we're building? So it is important to be able to have that. So we're gonna talk about that as well. Using Docker containers for environment isolation to avoid deployment issues. So does that apply to us? Does Docker container is applicable for data engineering solutions, just like you do for web applications and mobile apps and so on, right? And the answer is yes, it is. It is applicable. Then on your solution, your approach, right? You may, for example, you may create data pipelines with Python. That's code. That code has a lot of dependencies, right? Python has some dependencies on libraries, Python version, you know, PIP dependencies that you need to deploy. So you probably will need to isolate that environment. And a Docker container would enables us to build an environment, isolate it, so it's deployable, and guarantees that all of our dependencies are within that environment, within that container. And infrastructure automation with Terraform or cloud CLI tools. What that means is really when we're building cloud resources, whether it's a database, a data lake, some monitor tool, some data pipeline utility, or we're running code, we need to spin off databases, VMs, data lakes, and so on. How do we do that? Do we just manually do it, or do we automate this process? And what tools can we use to do that? So we will see more of that in detail down the road here. And of course, system monitors, notification, recovery to support operations. All those things are very important areas of our solution. And they're really important for the design and planning of any solution. System design architecture. What does that really mean, right? So in a system define, we clearly define what technologies should be used for specific areas of the solution, right? And we're talking about, do we use programming languages? Do we use no-code solutions and so on, right? So it involves all those decisions about how we're going to approach this, right? What tools are we going to use, right? And it also includes the high-level system architecture, which really defines how the components and what components are we using and how they integrate. So design is really the concept, right? It's the technical solution that how are we going to build this? How are we going to integrate the data? How are we going to use our storage and data processing tools? And it focuses on defining the technologies for each component, right? On the other hand, system architecture, which is a critical high-level design component, it really focuses mostly on how this data sources and data pipelines are going to move data across different components or subsystems or even systems, right? And basically what that means is you can be getting the data from an external system, and that data is going to cross multiple subsystems and each subsystems can have components. So the architecture basically lays out this high level diagram of how we're gonna and systems are gonna connect with each other and how the data is gonna flow. So it is really important. So for in this diagram, for example, this is really, if you follow the GitHub project, this is the basically the high level design architecture that we have for our project. We consume data in the form of CSV files. We process them through a data pipeline that runs on a VM and actually runs through Docker containers. And we spin off that VM resource using Terraform. And this ingestion layer basically communicates with an orchestration layer, and the orchestration layer basically handles um, the workflows and the basically essentially part of the data pipeline to ingest the data, to process the data. And we have orchestration tools to be able to monitor, schedule, and manage these resources. We also have a storage where we can probably move our data into a data lake for what we call the staging process, where the data is raw data and we need to basically process it, consume it, transform it by using data services, right? And the data services is part of the data pipeline where we load the data, we transform the data, and eventually the data that is processed, we move it into a data warehouse where the visualization and the analytics stage takes over that. One thing to notice also, this is also for if we are talking about real-time data services or integrations, we can use basically what's called a WebSockets, streaming services with tools like Kafka, a powerful enterprise service to be able to build message brokers that are consuming real-time data and are passing that data to platforms like Spark, where we can actually read files and we can read real-time streaming data for our data pipeline process. So what does that data pipeline in orchestration really looks or what does it really involve, right? And that's really the area where we actually do most of the code, right? But it has a lot of subcomponents in it. So but what it is basically is a workflow of tasks that can be executed in Docker containers if it is a code-centric approach. If it is a basically a no-code approach, those platforms usually will have a mechanism to orchestrate the data pipeline. And our focus right now is a code-centric, so we'll talk about Python and things that we need to build. The pipeline is this workflow task that can be executed, while the execution, scheduling, managing, and monitoring of the pipeline is referred as the orchestration. So orchestration is actually what makes that pipeline run, right? So the pipeline is can be designed or implemented with code, and the orchestration is all these tools and mechanisms to be able to make it go and run. So if we're talking about a code-centric approach, one of the ways to be able to run this, for example, if you're building something with Python, is to provision a VM and a data lake in cloud and monitor cloud resources through these orchestration tools, right? So if you're using a local approach like Azure Data Factory, that provides you with a turnkey solution where actually you do a lot of the stuff that you can do through code, you can do with the Data Factory. And the Data Factory basically governs all those concerns about the resources, how to manage the processes, how to monitor the processes, how to schedule, and so on. And definitely in this case, Docker Hub and GitHub can be used for the continuous integration, continuous delivery process. And basically what that means is if you have source code that you need to execute, you probably want to get the latest from your GitHub. And if you have a Docker image that you need to download and run, Docker Hub will be useful. It's a repository for Docker images, and we'll look at Docker more in detail if you're not really familiar. But just think about it: is Docker Hub gives you the ability to manage an image, which think of it as that package that you can execute, you can run, and it will spin off a container for your code to be able to run on that container. Of course, things like scheduling, recovering from failures are essential for the orchestration services, so we understand what is going on. And we have dashboards also to be able to monitor what is happening. Um, so what is the purpose of source control, right? And CI/CD. So basically, I know you heard me mention continuous integration, continuous delivery. What that really means is that as you do development, right? So as you do code and you make changes, you need to sort of maintain the version control of this, right? So you'll be able to use services like Git and GitHub for as an example to be able to make your code changes and commit and push those changes. Committing just basically means we're coding it, we're actually saving these changes and saving it to our history, and then the push means we're going to push it to the server so it's available to the entire team, and that's just part of software development lifecycle development. um, and the whole purpose is to ensure efficient collaboration, code control, source code control, seamless code deployment. So where continuous integration comes in basically is um, on how to manage the code and continuous delivery. What that means is how to build it and how to deploy it, right? So basically, as we make code changes on GitHub, we need to build and test the code, right? So in the case of, for example, if we have a Docker image that we need to build, we can build a Docker image, we can publish that image, and then we can actually download it through a process and test it out, right? If you don't have a Docker container, it's the same process. If it is just code, let's say you're building a Python solution, it is the same in a way that you build it, you make the code changes, you commit the changes, you push it to your server, but then there's going to be a process that I use as you push to that branch. You're going to build that code to make sure it's working. You're going to run some unit tests to make sure there are no failure points around time, and make sure that everything is working without defects, right? And you're gonna deploy this code into a VM environment, right? So essentially, it's the same process as opposed to just using a container. We can just deploy the code directly on a VM, which basically has the risk of not having the dependencies you need for your code. But that's why it is important to be able to do this building and testing and deploying to make sure you catch early on any problems, any issues. Um, so what is this Docker container and Docker Hub, right? So Docker provides basically a way to isolate environments, right? Docker is a technology where we basically create a self-contained environment with all the necessary dependencies. We all have been through this where we are doing development, and when the moment we deploy something, whether it's Node.js, .NET, Python, and we deploy to our target environment, it blows up because the dependencies are not there. Some of the libraries are older, or maybe they're even newer and they're breaking some of the code that you have. So what we do with Docker container enables us to actually, as we are developing and we have these target libraries and versions, dependencies, like let's say Python 3.9 and whatever other data libraries we need, that we control that version, right? And we make sure that when we build this container, this Docker image, we're able to say use this specific library. So regardless of the environment where we're going to deploy this, regardless of how the VM looks like, Docker will guarantee to us that our dependencies are isolated from the entire VM environment. Docker Hub, on the other hand, is more of a cloud based service that can enable us to distribute our containers, our data pipeline images which facilitates the provisioning of new environments. What that really means is that, for example, let's say we're building a new software, right? And we create a VM and we run it there, and we need to update it. If we're using Docker, for example, the way this will work is that we can use something like Docker Hub, and we push our image into Docker Hub. And now that's our code, basically, like similar to GitHub. Docker Hub just has our Docker image in there. When we deploy a new VM, what we do is on our CI/CD process, we go and download that Docker image into the new VM, and that way we can automatically spin it off and basically load it as a running instance, as a running Docker container instance. So Docker Hub serves as your centralized container registry, where you actually have the different versions of your code in containers, so you can download them in new environments. All right, so we talked about using some of the code. We talked about using um, some of this infrastructure. How do we build it? How do we do some of this stuff, right? So, but the thing is, we talked about maybe having a data lake, building a virtual VM, building a pipeline, data pipeline, data warehouse. But how do we get to build those things, right? How do we go there into the cloud, monitor or portal, and we spin off a virtual machine, a cloud storage, data warehouse? Do we do that? And yes, you can do that, but that's not a very reliable way to repeat the process. Meaning, if you do it manually, you're going to end up configuring environments differently, right? The virtual machine can be configured differently with less memory, more processing power, different things, right? So you run the risk of doing that. So ideally, what you want to be able to do is, when we're planning about spinning off our resources, that we define our resources by doing something called infrastructure as code, right? Infrastructure as code just basically means is the ability for us to code our resources, to code them and deploy them, just like you do actual code, just like we built our .NET or JavaScript code, but it's for infrastructure. So basically what we do is we configure, for example, the building of a VM using code, right? We can easily scale resources up and down based on this code. And by basically what we do is we update the configuration of the code, we deploy it, and it will manage some of the stuff. And this enables us to do this automatically. And we also, one of the big plus on this is, apart from the human error, is that we can track infrastructure changes in different versions. We can see when we introduce a different infrastructure configuration that maybe introduce a problem in our system, right? So we want to be able to track infrastructure stay and be able to minimize problems within configuration. So how do we do all this? How does all of this look, right? In a way. So let's take a quick look at how this looks. Let's take a look at the project. So I pointed out that the repo that we need to look at. It says it's part of the data engineering process fundamentals book, and you can take a look at that when you can. So when you go to that project, you're gonna find basically it's going to give you some background on what this project is. All right, so this project takes you from the concept of a comma separated value file, a CSV file, a data export from a system, into an entire data engineering process of how we build different things, right? So that's basically what this is going to do. So if you read the intro, the file from that project, it will give you background on all of this, reference book, and all this, what the problem statement is, what we're trying to achieve, right? That we're trying to build a geo fence type solution based on data that comes from subway systems, right? So you can read about all of this, how to do visualizations and all of that. But right today, we're focusing on cloud infrastructure, right? So cloud infrastructure, about that, we want to go to this folder. Step 2, cloud infrastructure. We want to look at the README file, okay? On that file, and this is all on the GitHub, okay? If you visit that repo, then we talk about data engineering design, all those concepts that we review on the slides. But in this case, what we're trying to do is basically talk about how do we do this, right? How does this Terraform works and all of this? How do we do this? So the first thing is, of course, you need to do the dependencies. We're not going to do this live because it will take us hours to basically download all the resources. But just understand that if you follow this file, you can basically install your Terraform dependencies, configure your cloud account. Let's say you're using, for this case, GCP, Google. You can configure your cloud account, create your role assignments, which is for security, right? And so there's a big area here to cover about those details. But just think about the fact that those configurations are applicable to every cloud provider, and you're just going to have to give the permissions once you do that. But the whole idea here is to enable the APIs and give permissions and be able to build this in a way that you can do it through code, right? So this is part of that CI/CD pipe. We're trying to build all of this, but this gives you the entire area of how to go about to do this, right? And then we have all the codes here, folders, depending on how we're going to do this. So for example, let's take a look really quick at what about Terraforms. What does that look like, right? So Terraform just basically, in a nutshell, is just a way to use metadata to be able to define like variables and define resources. So for example, here in the variables file, we can actually define what GCP project ID we need, what is the name of the data we need, and all the data resource that we need. And we configure what we need to build. And this enables us to be consistent about how we're building our resources, our naming conventions, our approach, and things of that nature. And all of this is in code. So you can just look at the Terraform folder, and you can actually look at the variables file, which is what I'm showing you on that README. And the variable files just look basically like that. You can define what region to deploy this, what project, and so on. So this basically is just defining those variables. That it will allow you to switch those variables if you needed to change certain things, right? To add other configurations and things and things like that. But then to actually use those variables, create a basically a main file that has the entire execution of what you need to build. So here's where we define what the Terraform version we need, what is the project, and when you see something like var project, var region, that's basically variable for project and variable for region, like we did here in this case, right? And if you don't provide that, of course, we have a description to say, please make sure to enter your GCP project. And where do you see that? You see that when you run this. Okay, so this gives us basically what we're building here is we're building storage, which is a data lake. We're building a BigQuery data warehouse, and we're building a VMM, right, with Ubuntu LTS. And so here we're building our resources, and this is managing this. But how do we do that? So we have those files. How do we do that? Well, that's part of that whole Terraform development lifecycle, where we actually go and excuse me, we actually go to it, and I'll show you. I'll scroll down here. So when we say how to run it, it will explain how to run Terraform and all that. But let's go back, because now I want to introduce Docker pretty quick here before showing you how to run it. So we understand a little bit of Terraform now. We understand there are files. We have them ready. We need to run them. How do we do that? We'll talk about that in a bit. But let's talk about Docker, right? So we also talked about Docker that we can use to isolate our environments and our dependencies. So this is an example of a Docker file. And this basically what it does is saying, I want to create a Docker image using this Python 3.9 as my base image. And I want to use a library called prefect 2.7, which is actually something that we can use for our data pipeline purposes because we're doing a code-centric data pipeline. And basically what we're going to do here is going to say we copy dependency files to our image. So this basically is another file. Is a file that is here under the Docker folder, Docker requirements, and it has dependencies, the versions that we need to deploy. So when we run this container file, what it will do basically, it will just execute. Sorry for the back and forth here. I don't know why I scrolled out of it, but it will just go ahead and copy those dependencies, right? So what it does here, basically, it will copy the file into your Docker container, right, on this. And then it will run all those Docker dependencies requirements. It would run pip install, which is a way, if you're not familiar with Python, to install libraries into Python environments, right? And then we create our folder structure for data and flow, which is really our staging, running environment to be able to run data and be able to copy data and things of that nature. And we copy the code into the environment. And all this code, all that stuff that you see being copied here is going to be in the orchestration folder. And you will see that there's a folder called flows, and that's actually all the Python code that we are actually running for our data pipeline. And you can open that and see how that looks, but that's basically just a way to execute flows for our data pipeline. So in a way, you can read here Docker summary, which is what I just explained. But how the development lifecycle looks for Docker, right? So essentially, we build an image. We build an image to the command line. So we use the CLI in some Docker commands to be able to say build image, tag image, run container, and so on. And so build image actually creates an image. And it's going to be a big image. It's going to be like a gig of data. And we tag it to know what the name is and what the version of that image is. We run the container, right? And so basically an image is just that unit of data that you can execute. And as you run that image, that becomes your container instance, right? That is actually running and loaded into memory in the environment and is able to execute your programs. But then you need to test, push, just like any development process. You follow the same things, the same process. You update your dependencies, you rebuild it, you update the container, and you push it, right? And you can remove all the images as you no longer use them because they take a lot of this space, right? And ideally, your images will be in your container registry, like Docker Hub, right? But from the CLI, these are the common commands that you will do, right? You would say Docker login to log into your Docker Hub environment, Docker image build with the tag, push to be able to push the Docker Hub. So you can read all these details, right? And as you can see, it's a lot of steps that we need to take care of. But this basically just gives you a run book to execute Docker containers, right? In some of the basic operations that you do with Docker, right? How to list the containers. And just to a quick reminder, a container is an active isolated instance of a running image. So remember, there's the concept of an image, but the container itself is the instance of that image running. And then some of these commands just basically is what you would do when you're doing the continuous integration, continuous delivery. You will automate the process to stop the container, remove the container if you want to, list the images, remove the images, or install a new image. So this is the process to be able to automate all of this, right? Let me see here. Just looking for questions here. Okay, so and how to run it is basically the run book to tell you, hey, go into the cloud, set up your account, set up your key, for your credentialing. How to run Terraform, as I said, I showed the code for Terraform. I didn't show how to execute it before. But basically what you do from the CLI the same way, and this basically is what enables us to do the continuous integration, continuous delivery process. Anything that we can type, we can automate, right? We can just run the script to do this. We can just run a bash script to basically execute this. So we'll say Terraform initialize, and what it will create a project with some state information, as you can see here under the folder structure. And then you will say, hey, Terraform plan, and you will say the project name in your variables. And what that Terraform would do with that, it would actually, if it is configured properly with access to your cloud infrastructure, it will go ahead and look at your files, at your Terraform files, and it will say, hey, based on what you're trying to build and based on this project, I know I'm going to have to build a data warehouse, a data lake, and a VM. And then gives you the chance to review those changes and apply them if you need to. So this is the critical step where we actually need to review, make sure that what we're doing is what we want to do and not create problems, right? So, and a way to apply that is we say Terraform apply, and it will execute this. And if you want to follow that continuous integration automation process, you can destroy all of it. Essentially what it will do is it will go to the cloud and destroy all the resources. And this is the quick automated way to automate your Terraform process, right? So the life cycle involves basically coding the files, looking at the plan, reviewing and approving, and then applying the changes, right? So this is the way to automate any cloud infrastructure that you need to build. Big companies do it that way. They don't have anybody just clicking and causing any possible issues. So you want to approach it and think of it in this way. Doesn't matter the project is small. If you do it this way, the rewards will be great at the end. And so how do you run this, right? So what is this now continuous delivery, and who executes this? Who runs this? So at that point, you can have what we call GitHub Actions or any other automation tool that you can use, like Bitbuckets, so many out there. But let's say GitHub Action. Here's an example. We can create a Terraform deployment file, and this is basically an example, right? What is this? This is the one when the way it works when you commit a change to a branch on GitHub and you have a data pipeline or a pipeline or GitHub action enabled on that branch, it will detect there is a new commit on that particular branch. And it will execute this file. And this file is basically a workflow file that executes a series of steps. So it basically runs it on a VM and is able to apply all these changes. So in this case, what it does is says, hey, I'm going to initialize Terraform, right? I'm going to log in with these credentials. I'm going to go to this folder, infrastructure Terraform, and I'm going to initialize a project. And then I'm going to, in this case, we can apply, but it's a little more complicated than that. We need to review the plan and be able to approve it, right? So, but this is just a very quick way to show you that you can initialize it and you can apply it using GitHub Actions. So let's go back. So with that, quickly, just take a look at this project, understanding a little bit better. And there's a lot of areas to learn and kind of automate everything we're trying to do here. So, but anyway, so this is a simple way to tell you basically the design and planning and data engineering is important and key. It's a fundamental step in the data engineering process to be able to build your infrastructure and guarantee that as you grow it and as you change it, that you have a repeatable, consistent process of delivering your solutions. So this is a simplified version of this. You can go ahead and visit the GitHub repo to read more, look at the code, look at the more documentation in there. Also, you can follow up with this book. It's available on Amazon. And yeah, it's a lot more in detail and more context about what we're trying to do. So please follow me. Scan that QR code if you can. Visit some of my repos, and I thank you all for being here today. I appreciate the visit. I see there are no questions, but we have covered all the material. Thank you so much for visiting us today, for joining us, and please with us. Follow my channel on YouTube, my blogs. Take a look at my GitHub repos, please. We have a lot of materials on AI, data engineering, and web development. But thank you all, and have a great day. Bye bye.